give me a minute to organize this. I have a lot of stuff here. My name is Ricardo Moran, and I'm going to talk to you about, well, the title of the talk is a new programming language for Arduino. Don't expect a lot from that title. It's a lot more simple than that. Let me introduce myself. I'm Ricardo. I work at Universidad Abierta Interamericana. I'm a research assistant, and we try to develop technology to improve education. Yeah, and in that regard, we usually use robots to do that. We think the robots are a very useful tool for kids to learn to program and learn mathematics, and essentially we believe that you can use robots for almost every class. So a couple of years ago we developed this tool. I'm not going to talk about this tool now, but I needed to introduce this new project. We developed this Physical eToys tool, which is a visual programming tool based on eToys. Some of you may know it. And Physical eToys allows you to control several robots. One of which is this is the Arduino. Probably you recognize it, but if you don't, the Arduino is a very popular board with a USB connection and a lot of pins that you can use to read or write values to sensors and motors, and with this you can very easily build your own robot or your own device. So in Physical eToys we have for Arduino specifically we have actually three, but two communication modes essentially. Let me put it in English. We have two communication modes. One that we call direct, in which the Arduino must be connected to the computer, and the computer uses the serial port to send commands and read the values, etc. And another one that we call compile, in which the scripts we built in eToys are compiled and translated to C, and then compiled to the board, and then they run independently from the computer. So then with this we have kind of like the best of both worlds. We have the live programming environment of eToys with the direct interaction with the real world, and we also can become independent from the computer and make a robot that doesn't need the computer and it's autonomous. Right? Well, for the compiled mode to work, a couple of years ago I decided to implement a smalltalk to C translator because the eToys scripts are actually smalltalk. Yeah. So I thought, well, this is fun. We can translate smalltalk to C and then use the Arduino tools to compile it and program the board. That worked. It was a disaster from the programming point of view. I'm not a programming language a language designer. I have no formal education on that, but I think it's fun, so I did it anyway. Although it has been done a lot of times. So probably my implementation was very bad, very wrong, but I did it and it worked, but it brings us a lot of problems. One of which is that the Arduino tools, the AVR compilers and stuff, are a complex beast. I have a lot of, and we have to distribute these tools with our Physical eToys, which make the distribution a lot large. I mean, kind of like more than 100 megabytes, and most of that is AVR compilers and stuff like that. So that's bad. That's wrong. And also the compilers are not cross-platform. Thank you. So we need to have one version of the AVR for Windows, another for Linux, another for Mac, and that's also a lot of complicated stuff that we don't like. Also, we have several types of Arduino boards, and each Arduino has its own configuration for the programmer, and you have to deal with that, and it's a lot of problems, and it works, but it kind of I don't like it, and I want to get rid of that complexity, right? So how can I do that? So I decided, since Ito's programming model is very simple, and you don't have a lot of, especially with Arduino, you don't have a lot of primitive operations you can do. Essentially read from the pins and write on the pins, and also all scripts are running an implicit loop. They have specific semantics that are also very simple. I don't need the whole Smalltalk translation to see in order to work, right? So I decided to take a simpler approach, one that Scratch for Arduino, for instance. Scratch for Arduino is another tool very similar, but it decides on a very simple approach. It doesn't have this compile mode, this direct mode. It only needs you to program your Arduino with a special firmware, and then it works, right? It doesn't have the ability to work independently from the computer, but it's much more simpler than our approach. So I decided we can do that. We can have a firmware on the board, and along with that, we can have a small interpreter inside this Arduino that will be able to run our programs, our Ito scripts directly on the board, right? So I decided to implement that. It's not complete yet, so I essentially don't know what I'm doing. I'm learning at every step. But I started working on that, and what? Good. So yeah, because I don't care if it has been done. I want to do it anyway to learn. I like to do stuff myself, you know. I called this project. I needed a name for this project, so I called it Uzi, because I will explain later why. But it's kind of like a show. Like the machine gun, yeah. So here I have my squeak image. I will show you. I will show you what I did with a couple of scripts. So an UCI program has essentially two things. First, everything that I show you here could fail, could not work, because I finished this kind of works. I finished it this morning, so yeah. So I was saying, an UCI program has essentially two things. One is the configuration of the pins. You can set them as input or outputs. So I can say, okay, this has as input the pin 10. Right? And each program can have a bunch of scripts. Yes? Each script as well can have a name. I can refer to it as with a name. For instance, I will make this kind of like the simplest program I can build with this interpreter, which will do something very simple, which is use the input from the button to turn on a LED. Yes, I will plug this LED, okay, to the 8 pin, and this button to the 10 pin. Yeah. So this I will call this script button 10. LED 8, right? I can say to the script these scripts are very similar to the Ito scripts. They have a tick rate. They have a name, etc. So I can say this will be ticking, yes, it will tick. The delay in which each tick will run, I can say, I don't know, 1 millisecond, and I can I have to tell it a bunch of instructions that I decided to use. So to build these bytecodes, I implemented an object that lets me more easily build the bytecodes, right? So this program is actually very, very simple. I just have to push the literal 8, then I have a stack, and I push the literal 8, I push the literal 10, which is where I have the button, and I execute the primitive get value, and then with that I execute the primitive set value, which will set, and it's very simple. With what I have in the pin 10, I set it to the pin 8. And then finally I say, okay, end, and that's all. If I execute this, and it works, I mean, it builds me an UCI program, which is, as I said, it has the inputs and the scripts. The script is only this one, because I didn't implement it anymore. I have the bytecodes, which are, you can see, sorry. So I have these 5 bytecodes, the different classes. I have the literals 8 and 10. I don't have any variables yet. I didn't even implement it yet, so that's there. And now this program, how do I install it here, right? I built another object which is the communication protocol. This is the UC protocol. This is a very simple object. It only holds the communication with the board, and I think I have it connected on the let's see, on the protocol connect on port COM3, and if I think it worked, it's connected. Yes, and now, for instance, with this I can say, okay, give me the value of the pin 10. For instance, I can say, okay, protocol get pin value 10, and it says 0. I can say, maybe if I press it, it says 0. Maybe it's not working. Right. It doesn't work because I didn't set it as input. But I can say, okay, set pin mode 10 as input, and now if I ask the value, it should work. I didn't press it, so I'm not pressing it, so it's 1. Okay. So with this, this kind of works like the direct mode I used to have, right? To execute the program, I built a kind of like a simulator. This is the first approach I did, which was a simulator. What?
I'm going to do it.
Oh, thanks. So I built a simulator which uses the protocol to communicate to the board, and the simulator, I can start it, and okay, of course, nothing is working, because I never told the simulator which program to run. And if I run this, then whenever I press the button, I don't know if you can see that I can turn on the LED pressing the button, right? There's nothing. This is not impressive. No. No, because the simulator is running on Squeak. That doesn't work, right? I need to run the simulator here. So the simulator is actually very simple. It implements all the. It's kind of like a visitor. I probably like the visitor button too much, so this simply runs on the computer and sends the commands to the board. Direct mode again. We don't need that. That already works. So. Yeah, this is exactly. Yeah, it's running this, but in the computer. I don't know. I don't really know what qualifies as a VM. I started talking. I call it a simple interpreter. Okay, I like VM more. So I built this VM inside the Arduino, and I have it here. This I don't pay too much attention to the indentation because I edit it in another editor, and it seems that it breaks the format, right? But this is very simple. I have, for instance, the interpreter class, which simply has an instruction pointer, a stack, the current script that is being executed and stuff. I have a program. The program is very simple as well. As I said, it has the configuration of the pins, which in this case I hard-coded the 3 because I have I'm using it the Arduino Uno, which has I think 19 pins. I don't remember, but this should be configurable in order to have several board types, etc. I also have the scripts, and I can, for instance, configure the pins and stuff like that. The interpreter can execute a program, execute a strip. All that is kind of obvious, right? I also have the script. The script has some other stuff, kind of like if it is ticking or not, when was the last time it ran, what is the delay between runs, etc. The literals, the local variables, the bytecodes, etc. And also I have the protocol itself, which lets me, for instance, I have these commands. I can evaluate, set programs, set values, set mode, etc. And it also, here is where I report the information back to the computer. Here I have the pins that are in input mode get sent back to the computer so that I can see what the values are and so on. Right? This is the implementation of the interpreter. With this in the board, let's see if this. I will disconnect the. Let me see the port, and I will program that in the Arduino. Now, let's see if this works. It was working this morning, so it should work now. Okay, it worked. No, yeah, it worked. It has 8 kilobytes, sort of. And now I can stop the simulator. I will connect again. This is working, and now, of course, the simulator is stopped, so this doesn't work anymore. But I can say to the protocol, okay, install program. And now, if I press the button, this time it is running on the Arduino, right? Another thing that the ito's model has that is very useful for kids is that you can have several scripts running at the same time, and the ito takes care of executing each one at the time it corresponds. So I could have another script running here. I will make the same program but with different pins so that you see. I didn't implement all the bytecodes, all the primitives, so I can do a lot of things now. But I will say it will be a potentiometer in LED 15 and a buzzer in LED in pin 9, right? And instead of pushing 8, I will push 9, and instead of pushing 10, I will push 15. And of course, I have to say, okay, we have another input, the 15 pin, right? So I will execute this, and now I can install this program, and sorry, I have a bug here. I don't know why, but sometimes this is necessary. This is still working, and now I have another script that will set this little thing in which I will connect on the pin 8 and 9. I'm sorry. And now this works, and I have 2 scripts running at the same time, which are really annoying, but I don't have another LED to show. So this one is the buzzer, and it takes the value of the potentiometer. If I turn the potentiometer up, it runs, and if I turn it down, it stops running. And of course, this one is still working, which is the other script, right? So this, of course, writing scripts. I didn't mention. I also have these programs, since we have very little memory in the Arduino, must be very compact. You know, I want to be able to program this in the Arduino Uno and even in smaller ones. So the encoder, I don't know if it's you know, I built an encoder that would let me encode program, and these are the bytes that represent these two scripts, right? This is the stuff that gets sent in a particular format, right, to the Arduino, and the Arduino then interprets them as the scripts you saw. Well, of course, writing the scripts this way is kind of a pain in the ass. You know, so eventually I will have a translator that will take the Ito script and build the bytecodes automatically. But until then, I decided, I don't have that, of course, yet. But until then, I decided to build a small. I don't know why I don't use this. A small, you know, parser that will, a very little language I built, you know, that will generate these scripts. This language is similar to Smalltalk, but it's not Smalltalk. It's not dynamic. It's not. It doesn't have objects. It doesn't have anything. But the syntax is kind of like Smalltalk. So, for instance, let's build this script in this syntax. You know, I say put on 10, let 8. This is not a hashtag. This is the script name. I can say its state can be, is it ticking now? It can be normal, which is not ticking. This is exactly the same as CTOS. I can say now how many times per second or per minute or per hour it will run. In this case, it will run 1,000 times per second. And the body of the script runs between square brackets, and it's simply at pin 8 put at pin 10. And that's all, you know. This is the syntax I decided to use, and I have a parser. This parser is, since the syntax is very similar to Smalltalk, I used the Smalltalk parser, and this, let me see. This builds, you know, a syntax tree, which has a script node with the name, state, the ticking rate, and a body which is only one statement, the message send, which is an implicit message send. It doesn't have a receiver, you know. It's output with one argument, which is another message, a number node, no, two arguments, sorry. Two arguments, first one being a number 8, and the second one being another message, which is at 10, right? This is very, very simple stuff. And of course, I can compile this. So compiler new, and compile string, and this will build me a new C program that now I can install in the computer, install in the Arduino, encode it, program, simulate, etc. In fact, this script is exactly the same as this one we did earlier, but by hand, except for the inputs, because I didn't say here anywhere which pins were going to be configured as inputs, right? In fact, I don't have the syntax yet. So we can see that it has the same name, it's ticking, it has the same delay, it has the same bytecodes, and of course, the same literals. So that's all I wanted to show you today. What are the limitations of this? Well, of course, this is not a complete general purpose language. This is very simple, it does what it does. It was made for that and nothing more. It doesn't have objects, it doesn't have meshes, it's completely static. It probably is very slow. I haven't measured it yet. I don't care too much about that, because normally the scripts don't really need a lot of speed, but it will be interesting to measure that. And it's a work in progress. I haven't had a lot of time to spend on this, but it still lacks the implementation of all the bytecodes, all the primitives. For now, I only have primitives to read and write pins. I don't even have a arithmetic build yet. I don't have implemented variables, so it's still very early. But I wanted to show you anyway. And of course, the other part of the project will be integrating it into physical itoys, so that physical itoys could use this and become a much smaller, much simpler, and of course cross-platform, etc. So I think that's all. Probably forgetting a lot of things, but thanks. So, questions? Question. Thank you. It's very important for me that you.
Another question. No, I'm wondering. I know that Ito is a complex system.
Yeah.
It lets you open Smalltalk browser
Yeah.
and use the scripts with Smalltalk, which is like guiding the keys and the user slowly into Smalltalk. I think is one of the best differences between Ito and the Scratch. Let's go further.
Yeah.
And with that in mind, I understand that eventually you will need full Smalltalk or something very complete running in the Arduino. But without going that far, right? Restricting us to the most normal use, the beginning use. How much do you think you need for this interpreter to run the normal Ito script? Do you need variables? Do you need keys? Or
Yeah. Yeah, I decided, I didn't talk about the technical stuff very much, but I decided to have, each script has a couple of literal variables, local variables, sorry, and a program has a couple of global variables that it will use, share among these several scripts. So I was thinking that these global variables could be...
Is that for Ito or for your...
No, for mine. Ito already has a lot of other stuff. I don't want to bring a Smalltalk entirely here, but I want to translate only the stuff that the Arduino can do, and the other stuff leave it apart. But I do want to be able to, when this Arduino is running and you have it connected in the computer, everything runs the same. That's why I did the simulator running here, so that I could have both worlds. But when the Arduino is not connected to the computer, it should work anyway. It should have, for instance, if you are using the extent of the world or the property of a morph, it should be able to use that, although it doesn't exist on the... Yeah, what? Yeah, it's very common. It's common if you use the connect, yeah. But I would like, to have a control panel here that works when it's connected. It runs some specific behavior, and when I unplug it, it still runs the behavior, but it's not reporting anything yet here. So I need that sort of stuff anyway. So I was thinking of implementing that as global variables, that when they are connected, they report the value back every, 10 milliseconds and stuff. And if not, they don't do anything, and they stay there and such. That's still not done. But yes, it's kind of like the idea. That way we could lose completely discard, the idea of direct mode, compiled mode, which is kind of confusing. I don't like that anyway. So this should run always here, but this should always work, something like that. Well, thanks. Ya me voy, che.